Okay, today's lesson we'll be looking at percentage yield. So this is just an extra step that you need to undertake after you have found the reacting mass. So in the reacting mass topic, you are essentially learning how to find the maximum theoretical mass. So to work out percentage yield, you do actual over expected or actual mass over theoretical mass. So probably a better way of writing it would be that percentage yield, is the way I like to do it, equals actual mass over maximum theoretical mass the whole thing times 100 because it's a percent. So ultimately you're doing actual over theoretical and you're multiplying by 100. You can either do it with moles or with masses. Normally people do it with masses. So if we look at this example, 100 grams of ethene, which is this one, reacts with steam to form 110 grams of ethanol. What is the percentage yield? Now, you have to first find what the maximum ethanol should have been using the method I showed you before, which was moles ratio mass. So you do moles by doing 100 over the MR of this, which is 28, and you get 3.57. You look at the ratio as 1 to 1, which means there's no need to change the 3.57 because this must also be 3.57. Then you find mass by doing moles times MR, so 3.57 times ethanol, which is 46, 12 times 2 plus 6 times 1 plus 16, and you get 164. So the maximum theoretical mass should always be the bigger number on the denominator. You put that on the bottom and you put the 110 grams that they gave you, you put it on the top and times it by 100 and you get 67%. So you just need to be aware that the 110 over 164 is the way to work it out. Don't think, oh, it's 110. I already know how much mass was made. No, that's the mass that the person got in the experiment. The 164 is the maximum theoretical mass. That's the mass they should have got. So in reactions, when you carry out experiments, you will never get 100% because there can be stuff that occurs along the way. So by stuff along the way, I'm going to show you some top reasons for why the percentage yield might not be 100%. In an exam, it will be recommended that you learn at least 2 or 3 of them. So these are my top reasons that you should write down. Number 1, the reaction was incomplete. That's one of the most famous ones. So if you don't do the experiment for long enough, then obviously the reaction is not going to form as much as it should have. The second one is also famous. Products can be lost during the separation steps. So that means if you pour one container into another, then into another, then you filter it, then you heat it, each time you leave behind a little bit of product on the container. Side reactions can occur, which means instead of the main reaction happening, there might be another reaction that happens off to the side. The reaction could be reversible. You've met the reversible sign, which means your yield won't be 100 because as soon as you form your product, the product will turn back to the reactant. And the last one's also quite good. In school, in a school lab, they might give you cheap starting materials. So they may not be completely pure. Now, if you think about it, if your reactant is not pure, how can you get the maximum amount out of it? You can't. So I would write these down. My favorite are the top 2. And that's what you would answer in an exam when someone asks you why is the percentage yield not 100. It will usually be a 1 or 2 mark question. Okay. So I will go over one more example. So this is the worksheet. This has actually broken it up into steps. They're all broken down into steps. So first they make you calculate the maximum theoretical mass, then they tell you how much is made. So let's just use number 1 as an example. Now, I'm assuming that you've practiced how to find the mass already in the previous lesson. That's why I'll go through it relatively quickly. Step 1, moles. I always say to people, if you're stuck in a chemistry question, just find the moles of something. You'll be guaranteed marks. So 12 grams of hydrogen. Hydrogen is H2. 2 times 1 is 2. Do not include the 3. 3 is a big number. You only include the little numbers. So 12 over 2 is 6. Now the ratio, let's see what they want. They want the mass of ammonia. So we found this one, we're looking for this one. The ratio is 3 to 2. This one's one of the harder ratios. Now the hydrogen is the 3, so the hydrogen is 6. So what's X? Well, you could think 3 times 2 is 6, so 2 times 2 is 4. That's one of the easiest ways to do it. So X equals 4 moles. Alternatively, you could do 3 divided by 1.5 is 2. So 6 divided by 1.5 is 4. So mass is moles times MR. The moles was 4. And this one is 14 plus 3 times 1. Do not include the 2. That was taken care of in the ratio step. So when you times these two together, you get 68 grams. Now that's nicely bigger than this, because this is how much they actually got in the experiment. So the yield will equal 65 over 68 times 100. And that will give you the percent yield, which happens to be, in this case, very high, 95.6%. Then it asks you for 3 reasons why the yield is not 100. I will show you these as per the mark scheme. Okay, reversible reaction, incomplete reaction, side reactions, product lost on separation. Just learn them. So I suggest you just practice the rest of this worksheet, because you'll get good at reactive masses and you'll be applying the percentage yield formula. One thing I should mention, if you ever get a percentage yield bigger than 100, it could be that the reactants, the product that you made was wet, so it contained water, and you were supposed to get a dry product. So if it's wet, it's going to be heavier than it should be. And that's really one of the only ways to get more than 100% yield. Okay, that's the end of this lesson. Next, depends on your syllabus. You might be doing atom economy, or you might be moving on to empirical formula. Okay, so see you next time.